The end is coming. Since we first looked at the stars, we've wondered how this cosmic show will finally wrap up. For decades, the answer seemed simple, with three main theories cosmologists debated: the Big Freeze, the Big Crunch, and the Big Rip. But it turns out the universe is far weirder than we ever gave it credit for. Recent discoveries are painting a more complicated, and frankly, more terrifying picture. The neat and tidy endings have been tossed out, and the latest data suggests we might not have a clue how the final chapter is actually going to be written. For a long time, picking our apocalypse was like choosing from a menu with three options. The frontrunner was the Big Freeze, also known as heat death. In this scenario, the universe just keeps expanding forever. Stars burn out one by one, plunging the cosmos into an endless night. Over trillions of years, everything cools down until the universe hits a state of maximum entropy, a vast, frigid void where nothing can happen. It's a slow, quiet, and profoundly lonely end. Then you had the more dramatic Big Crunch. This theory suggested gravity would eventually win its cosmic tug-of-war against expansion. The universe's sprint outwards would slow, stop, and reverse, pulling all of existence back together into an infinitely hot, dense point, just like where it all began. Some even theorized this could lead to a big bounce, a cosmic reset button kicking off a new universe. And finally, the most cinematic ending: the Big Rip. In this model, the expansion doesn't just continue, it accelerates uncontrollably. Driven by a superpowered form of dark energy, this expansion would become so strong, it would overpower gravity itself. First, it would tear apart galaxies, then solar systems, planets, and finally, the very atoms you're made of. For years, scientists tried to figure out which path we were on, but it became clear one mysterious ingredient was calling the shots. And the fact we know almost nothing about it is why we're so uncertain today. That secret ingredient is dark energy. It's the placeholder for the unknown force making the universe expand faster, and it makes up about 70% of the cosmos. Yet, we're shockingly ignorant about what it is. Is it a permanent, unchanging feature of space? Or can it evolve? The answer changes everything. The leading theory was that dark energy is a cosmological constant, an unchangeable energy of space-time. If true, the universe expands forever at an accelerating rate, leading straight to the Big Freeze. For a while, this seemed to be where the evidence pointed. But what if dark energy isn't constant? An idea called quintessence suggests dark energy is a dynamic field that can change. In a fascinating twist, recent data from the Dark Energy Spectroscopic Instrument hints that dark energy's influence might be weakening. While not yet conclusive, a model where dark energy evolves fits the data well. If this holds, the universe's acceleration could slow, perhaps letting gravity trigger a big crunch billions of years from now. But there's a third, frightening option. What if dark energy is phantom energy? This hypothetical form would grow stronger over time. If so, the acceleration would become exponential, sending us on a one-way trip to the Big Rip. Right now, we're at a cosmological crossroads. The Big Freeze is a strong contender, but the simple idea of constant dark energy is being challenged. Future observatories, like the Nancy Grace Roman Space Telescope, are being built to study dark energy with incredible precision. They'll help us figure out if it's constant, or an evolving force leading to a fiery collapse or a catastrophic rip. Let's jump trillions of years into the future. The last star has flickered out. In a Big Freeze scenario, the universe will be ruled by its final inhabitants, black holes. These gravitational monsters will be the last major players, slowly gobbling up any leftover matter. But even black holes aren't forever. Thanks to a quantum effect predicted by Stephen Hawking, black holes slowly leak energy via Hawking radiation. This causes them to evaporate over almost unimaginable timescales. As they shrink, they evaporate faster, ending their lives in a final flash of energy, one last firework in a dead universe. This evaporation, however, creates a huge problem: the black hole information paradox. A core rule of quantum mechanics is that information can never be destroyed. But according to general relativity, once something crosses a black hole's event horizon, it's gone. So what happens to the information of the matter a black hole swallows? Is it erased from reality, breaking physics as we know it? Or does it somehow leak back out? Solving this is crucial to understanding the universe's final state. If information is lost, our understanding of physics is fundamentally broken. Some theories even suggest all massive dead objects might evaporate over eons. This could mean the universe's final timeline is much shorter than we thought. The universe's last act isn't just about expansion. It's about the ultimate fate of matter and information itself. Beyond these main contenders are even weirder, more speculative ideas. One of the most compelling is the Big Bounce. This theory suggests our universe is just one episode in an endless cycle. A big crunch wouldn't be the end, but the beginning of another Big Bang, creating a new cosmos from the wreckage of the last. Another wild card is the idea that the laws of physics aren't set in stone. Over cosmic time, the fundamental constants we rely on could shift. New types of matter or energy could appear, leading to a future our science can't predict. Then there's the Big Slurp. In this scenario, a bubble of a different, more stable type of vacuum could appear. This bubble would expand at light speed, rewriting the laws of physics and instantly obliterating everything in its path. These are fringe ideas, but they drive home a critical point. The universe's destiny is anything but settled. These are the questions that keep cosmologists up at night. The clues to our ultimate end are hiding in the faint light of distant galaxies and the bizarre physics of black holes. If you find these cosmic mysteries as fascinating as I do, make sure you subscribe and ring that bell so you don't miss our next trip into the unknown. So how will the universe die? The honest answer is we're less sure now than a decade ago. The Big Freeze still seems like the most probable outcome is a slow, cold, lonely end. But the latest data has thrown a wrench in the works. The possibility that dark energy is weakening has reopened the door to a distant Big Crunch. And the terrifying Big Rip remains a dark horse, a possibility if dark energy is more aggressive than we imagine. The fate of the universe isn't a story that's already written. The final chapter depends entirely on the true nature of the darkness that fills our cosmos. For now, all we can do is wonder, staring into the endless expanse, knowing that the end will come, but not knowing if it'll be with a whimper, a bang, or a rip.